Hello. So, how are you? Fine? Okay. So, first of all, I welcome to all of you on my channel and whoever following me and for your support, thanks to them. And further, if you like my channel, please subscribe. And if you want the notification for the next class, so you have to subscribe and this will be support for me. So in this series today we'll move further with another topic in law of integral exponents. Law of integral exponents we'll see further, as you are seeing on the board that one important law is written here. It is very much important, right? It is going to have a great impact on today's class or on your study, right? We'll clear the basic of this law, and with this I will see another law also. So first of all I will see this law, right? So be attentive, and as I have told you, need not to go anywhere, stay with me patiently, right? But have some patience, will clear all your doubts, right? So now let us start. As I have written the formula, a to the power m upon n equal a to the power m 1 by n, or a to the power 1 by n or m, and a to the power m and root under a to the power m. It is a very much important, and I will clear this all steps one by one, right? So before that I had discussed with you this formula, right? Suppose if it is a to the power m or n, so here power is multiplied. Gentlemen, what is that? Power is multiplied, right? So please remember this or recollect this, that power is multiplied. Okay, that power is multiplied, right? So here we are following the same thing. Now we'll go through the step by step. So first of all we'll see this, why this equal to this, right? Okay, if you follow this step here, I'll take example, no doubt. I will take example. I will clear everything, right? I am not going to leave any type of questions, right? This is my promise with you. This is my promise with you, right? I will complete my promise. Okay, just have some patience and just listen carefully. Go through this and practice at your home. 3 mantras I have already discussed. Practice, practice, practice. Math is a matter of practice, right? So a to the power m upon n. Why I have written this a to the power m into 1 upon n? Now just I am going to explain this. First of all, this is the first step that I am going to explain this. Based on this, right? See here. Now a to the power m upon n, can we write a to the power m into 1 upon n? Can you write? Can you write m into 1 upon n? Can you write? Yes, very good. I can write, because m into 1 m or upon n. So result is same. There is no change. There is no change. If you solve the math, you must remember that the left hand side and right hand side are same. So whatever we write in math, every in left or right, it means that says we are equal. We are equal. That's why it is written in this equal sign. This is the main purpose of this, right? Why we write the equal sign? It means left and right are equal. So m is multiplied by 1 upon n. So m upon n, that I can write, right? Okay, okay. Now further I have written this. Again, can you write this? a to the power 1 upon m into m. Can you write this? Because the same thing, m into 1, m upon n. Here m into 1, m upon n. So basically this part and this part are equal. These all three parts are equal. All are in equal sign. Right. Further we have come to this place. Before coming to this place, I will explain many things before this. I want to explain much more things. Why it is written in this fashion? Why it is written like this? Gentlemen, this is going to have a great impact on your solutions. Before that, how you are solving, I don't bother. But after this class, you will solve the sum smartly. It's my promise. You will solve the sum smartly. This is my promise. Just listen this. How it is. Okay. Now I am going to do this. Because I have cleared your first, second, third step. Now fourth I am here. Right. Okay. Fourth I am here. Now this I am deleting this because I have cleared this. I am taking this step as I have written. Why can you write like this fashion? Right? How can you write like this fashion? N root under a to the power m, and I have written n root under a and in bracket power m. Right? I have written like this. So I will clear this. I promise. Now, see why I have written. So I am going in depth. First of all, what can you write this? Root x. What can you write this? Root x. What will you write if it is here x? If it is here x, what you write? What you write if it is here x? Root under x. Have you got the root of the sum number? Yes, certainly in the previous classes you must have got root of the sum digits. That you know how to get the root, right? Suppose, for example, if you have to find out the root of the 16, how will you get the root of the 16? Just, gentlemen, we are going into the basic, very basic. That I have promised you. I will start from the grassroots level, right? Please cooperate. Now root 16. How you are going to get the value of this root 16? How? Certainly you will tell me, sir, first of all, I will factorize this 16. This is the basic method that you have gone in 7th class, 8th class, 6th class. I think 6th standard onwards it is in your syllabus, right? So first of all, you will factorize this 16. How will you factorize? 2 8 ja 16 you are writing. 2 again 2 4 ja 8. Again you are writing 2 2 ja 4. Isn't it? This is correct. Okay. Now what you are going to write? This root under 16, what are you going to write? So you will write this 2, this 2, this 2 and this 2. You are going to write? Isn't it? Okay. So gentlemen, this is a very basic method that you know that out of this 2 digit will get 1 digit. Out of this 2 digit will get the 1 digit. So your answer will be 4. Right? Have you thought why we should take the 2 digits, that the same digit, and I will get the 1 digit answer? Why? Have you thought? Have you analyzed the things? Because root says here 2 presents. Root says here 2 presents here. 2 presents here, gentlemen. 2 presents here. That is a silent. But 2 is there. You might have seen in the math sometimes some question like this. You might have seen get the value of this. You might have seen the question like this. The question like this. Why? Because this 3 shows, this 3 shows that the similar digit, because before solving you will factorize like this. This I will discuss this also. I will discuss this also. I am not going to leave this. I will discuss this also. That's why I have put up these questions. Right? This shows that the similar 3 digits, your answer is 1 digit. It means out of the 3 similar digits, your answer is first digit. Any one you can take. Like how you are going to solve this, gentlemen. Just this is a very slight example I have taken. Here 3 is written. So 4 into 4 into 4. 4 4 just 16, 4 just 64, and 3 is there, 3 root under this. So your answer is 4. Your answer is 4. Same pattern. Here 3 is written, that you are able to see that here 3 is written. But here 2 is not written. 2 is silent off. But I should understand there is a 2. Right? I should understand here is 2. So gentlemen, that's why I have taken under this 2 similar digit I have taken your 1 answer. This 2. Again this out of this 2 digit I have taken your single digit 2. And we multiply this 2 2s are 4. 4 is your right answer. I think it is clear to you. I think it is clear to you. Okay. Based on this, I will take much more question. So that I will clear your this law of integral exponents. Which is going to save your time in your exam. Which is going to save your time in competitions exam. Where it is going to solve your big questions in very few seconds. That you can take a 20 seconds. It is a requirement of the today's competition. That is 20 seconds. Within 20 seconds you have to solve the one math. Can you solve this? Yes. If you remember this basic things, you can solve the question in 20 seconds. It's my guarantee. But you have to remember this. Come on. Now I am going to solve this question. That I have told you 2 is present here. If 2 is not written here, not necessary to write, but if you write, there is no mistake at all. Right. Now I am going to solve this. I have given you some examples. We'll clear, right, more examples. Right. So, here is 2. What is 2? Here is 2. Gentlemen, here is 2. And if again power is 1. Here is power 1. There is no issue if I write 1 power. There is no issue if I write 1 power. This is going to solve and this is going to give a great result. You won't believe this is going to a great result. That I have told you this is a 2. Again here 1 power. So answer you can write, gentlemen, x to the power 1 upon 2. 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 Because 2 presents here. 1 is here. That is a power. Again this power comes this place, and this you out of this power comes below. That makes their denominator, and this is numerator. So x to the power 1 upon 2. X to the power 1 upon 2. Gentlemen, like this. If it is here 3, and if it is right here p, and it is a 2. So what can you write? You can write p to the power 2 upon 3. Isn't it? Can you write p is p to the power 2 upon 3? So gentlemen, now we are going to solve a very good questions. How can you solve this? Right. We'll take some more examples, because this is a very much important law of integral exponents, part of this. Right? Now, if in this in place of p, if you are writing in place of p, if you are writing some digits, suppose here it is a 4. Here it is a 4 root under 4. What can you write? 4, no, write here 9, no issue. root under 9. So you will write 9 to the power 1 upon 2. There should not be any type of question in this. If I write, if you get the solution like this, you should not have any questions, because gentlemen, you know the 2 presents here and 1 is present here. So we write 9 to the power 1 upon 2. Gentlemen, please note my point. If there is some 3 power and here it is 8 and here it is some 5 power, so what will you write? What will be the answer? Answer will be 8 to the power 5 upon 3. It is correct? It is correct? It is correct or not? It is correct or not? It is correct. It is correct. It is correct. Right? Because that you know very well, this comes here, this is a denominator part and this is your denominator part. Isn't it? Isn't it? So with the help of this, we can solve much more questions. With the help of this, we'll solve more questions. Just note it down and have practice at your home. Right? And have practice at your home. Now we'll take some another examples. That will be very good example. So I have cleared this first step. So I have cleared this m to a to the power m upon n. No, just opposite. Vice versa you can write here. If you get somewhere 5 to the power 2 upon 3. 5 to the power 2 upon 3. Vice versa. What can you write, gentlemen? What can you write? That I have told you that this power, this 2 or 3, there should not be any confusion. This is your denominator part, this is your numerator part, so that you know numerator part where it is written. So gentlemen, can you write like this? It is correct? It is correct or not? That the same thing, because again 5 to the power 3, as I have told you, this 3 is denominator, that is numerator 3, and 5 square, it is a numerator part, this is a denominator part. You must remember, this is a numerator part and this is a denominator part. That, gentlemen, the same thing I have got here. Just look at this. Here is m upon n. This is your numerator part, this is your denominator. So here you are writing this n comes here and m is a power. The same thing I have written. Even you can change this like this, power m also you can write like this, that n is a to the power. Whether you write here m or doesn't matter, so it will be m upon n. If you solve this, a to the power m upon n will be the right answer. Gentlemen, are you getting my point? The same thing. If you write, if there is a 4 to the power 2 upon 3, what can you write? So under root 4 and 3 is here, power is 2 here. It is correct, gentlemen. It is correct. I think I have cleared the very important law of integral exponent that I have written on the board, and it is clear to you, I think so. Okay, if you are not clear, if you have any type of doubt, I would be happy to reply your comment on the same topic, or whether you want some another topic also. If you want some another questions to be solved here, you can write in the comment box, that I would be happy to reply your comment, and I will get the complete answer with the solution in the next class. Right? Okay. So before this, I will take some examples based on this question, because this is a very much important question, and we'll solve 2 or 3 questions based on this. So I am going to solve this. Now I will take some another example, which is very much important example. Right? Okay. So gentlemen, I am going to have some another examples, right? Clear? I'm going to delete this. You can have a screenshot of this. Okay. Okay. Now, just remember this, because we'll solve the questions to take this law of integral exponents, and some type of questions like you will get here. Suppose another, that is a to the power m into a to the power m, a to the power m, and that you a to the power m. That I think you have already solved. There is some different a to the power m, or here it is written some different type of b to the power m. Yes, what can you write this? This is a question. M to the power m or b to the power m. What can you write this? So a and b will be multiplied. Power m is safe. There is no issue. There is no issue. We'll take another example for the based on this. If it is a 4 to the power 3 upon or 2 upon 3, 4 to the power 2 upon 3, and you can have 6 to the power 2 upon 3. So what will be the answer? Gentlemen, no need to do much more things behind this question, but we can solve it very easily. That you multiply this 4 into 6, power is still still, so 24 power 2 upon 3 is the right answer. Gentlemen, 24 power 2 upon 3 is the right answer. Isn't it? 24 upon 2 upon 3. This is the another law of integral exponents that you can remember. You can write in your notebook, and you must have practice at your home, right? As I have told you that I am not going to leave any type of questions from this chapter, law of integral exponents. So I am not going to leave this. Right? Now we'll take some another example or questions. Come on. Okay. Be prepared. You must have a notebook. So before writing the question, just if I write the question, answer should come from your end. That what I expect from you. At least this much I can expect from you. That if I write the question, I will leave the question for seconds. That answer should come from your end. Now question is root 5. Okay, very good question that I am going to write. Root 5 to the power minus 3 and multiplied by root 2. Again power is minus 3. So what will be the answer, gentlemen? What will be the answer? Try to solve this and utilize all the formulas, all the law of integral exponents that we have gone through, right? So just utilize them and try to solve this. Certainly you will tell that, sir, root 5, can we write 5 to the power half? Can you write this? Because just we have discussed 2 presents here and 1 is here, to 1 upon 2. Again the power comes minus 3, right? If there is no sign between this bracket, we know there is a multiply. There is multiplication sign, so we'll write the multiplication sign, right? Again what we are going to 2 to the power half, again to power minus 3, isn't it? Again power minus 3. So gentlemen, that 2 to the power half and power is minus 3. Now what you are going to do this question? Please remember law of integral exponents. That says that if there is a to the power m into n, this power is multiplied. I want to write this in short, that you might remember this, a to the power m into n, that is a to the power m into n. That you can remember this. That you can remember this. So can you write, can you multiply with, can you multiply this power? Can you multiply this power? Yes, I can multiply this power. I can multiply this power. So what will be minus 3 into, so we'll write here half into minus 3. Again here it is 2 into half into minus 3. Can you write? Can you write half into minus 3 here also? Here also? Can you write? Yes, 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 I can write. Because if power is in a multiplication form in this fashion, power is multiplied. So gentlemen, what will you write the answer? 5 to the power minus 3 into 1 minus 3. So you can write here minus 3 upon 2. Again 2 to the power minus 3 upon 2. Can you write? Can you write minus 3 upon 2, minus 3 upon 2? No, no, no. What will you do? Now what will you do? That I will do. What says now this sum? Can you remember this? As just now I have discussed that a to the power a to a to the power m and b to the power m. So what should I write? A into b to the power m. Can you remember this? Just now we have discussed. So we can multiply this 5 into 2. So we can multiply this 5 into 2. Can you multiply? Can you multiply this? Yes, very good answer. We can multiply. So 5 into 2. So we'll write here, gentlemen, 5 into 2 and power minus 3 upon 2. Power minus 3 upon 2. So we can write this. We can write this. Now what is the answer, gentlemen? 10 to the power minus 3 upon 2. 10 to the power minus minus 3 upon 2. Can you write? 10 to the power minus 3 upon 2. This doesn't end here. This doesn't end here. We can extend this in another form. We can extend this. If you want to extend this, we can extend this. You can write here answer also. There is no issue. But if you want more solution, if you want more solution of this answer, we can provide the another solution also. Right? What can you write? What can you write? What solution you can provide? In decimal form, we can get the answer in decimal form. Right? We can get the answer in decimal form. But at this juncture, this doesn't require. You can write this answer. Further you can break this. That we know the formula, this root, that last law of integral exponent that we have discussed, that you can write this like this answer, that your 10 will be here. 10 is the power root under 10. So what is that? This is a 2 and this is a minus 3. Can you write? Can you write? Yes, we can write. We can write. We can write. Because that we know 2 is here, because 2 is given here, 2 to the 10 to the power minus 3. No, this minus 3, you will confuse that why should I write this minus 3. Again we can solve this, no issue. So root 2 under 10 to the power minus 3, this is your question, how to remove this minus sign. So you can write 2 1 upon 10 upon 3, 1 upon 10 to the power 3. You can write this also. But this is a standard answer. If they require exponential answer, you can write this. If they require some another format answer, you can come up to here. Again, you can multiply this. You can get the answer. There is no issue. Right? Anything? Okay. With this, you can note down this question. We'll take some another example. And that we are going to break this. Okay? Now, you can note it down. Okay. You can note it down. I will leave some questions for you. That you have to solve. You have to give an answer in the comment box with the complete solution. Not only answer. I am not happy with if you are providing the answer only. No, I would be happy if you provide the complete solution step by step. How have you solved the questions? Right? I am going to put the homework for you, that you can understand homework for you. So please, I will solve the questions in the next class. So till that, you have to solve the question, and I would be happy to see your solution in my comment box, right? Okay, okay, thank you. Till now, if you have not subscribed, please subscribe, like and share. This will be a great support and this will be a motivation for me for the next class. So if you want the notification in advance, please subscribe it, right? Thank you. Again, I welcome to all of you on my channel, right? Thank you. So I am going to delete this. First of all, yeah, I am going to delete this and I'll put some questions, right, based on this. That we have already discussed some. We have already some discussed that law of integral exponents. I'll put some questions based on that so that you will solve, right, and reply your answers. Please note down the question. Please note down the question 25. 25 oh, 25 power minus 1 upon 3 and multiply root under 60 3 root under 16, right? This you have to solve. Just very simple one question. Very simple question. 25 to the power minus 1 upon 3. 3 root under 16. Right? So I will understand that you have cleared this formula. Again, another this second question. Second question 1 upon 3, right? 4 or power is minus 5. So this question you have to solve. These two questions, get ready with these two questions and get solved. Thank you very much. Thank you for your great support and we are meeting in the next class. You can note down this question.